Yes, again. I am Trish McCall, and we are live from the 2019 HPCC Systems Community Day, and we are now moving into our breakout sessions. I have the pleasure to introduce one of our speakers in the Usability Improvements theme. He has worked with ECL since 2016 and is currently a senior data scientist with Proagrica. Here to talk about the Dapper tool, a bundle to make your ECL neater, please welcome Rob Mansfield.
Thank you. Okay, thank you. So what I've done is I've made this deck really elastic. So I'm just going to start talking about things and make it as interactive as possible. Feel free to interrupt me and ask whatever you want, and we can talk about all the different concepts. I don't have an IDE, so we might have to get a bit conceptual, but we can talk about whatever you want, which is exactly what this slide is to remind you about. All right, so first thing I want you to do is close your eyes and put your hand up if you think ECL can be a little bit too verbose, just so you won't be biased when you vote. So I personally think that the language can be a bit difficult to wade through sometimes, especially if you try and do something quickly. And I think there's a few use cases where this isn't especially big problem. So you've got QAs, like people that are doing quality assurance on your code and the outputs on the tables that you make, don't want to be doing complex join operations. They want to get in there, answer the specific questions they have, and get out. And a similar thing is true of analysts and of data scientists. And to an extent, developers, if they want to hack together a quick test script, or if they want to just see whether something works, they want it quick and easy, and maybe a little bit dirty. And there's parts of ECL which don't really align themselves with this. I apologize, there will be bits of code here. I'm going to talk about them with amusing anecdotes and things to make it entertaining. But you can see, so to dedupe, you have to dedupe, sort, distribute, hash, local. It's a bit of a pain. Project, again, all I really want to do here is add one to one column, and I have to write all that code. And for a group count, if I put it on the bottom of this slide, the text got really small. So I think there's places here where stuff can just be improved. It's not that it's a bad language, definitely not saying that. It's just that sometimes I want to do stuff quickly and without having to look up exactly all the operators, I need to write a CSV properly so I can read it into R later. Well, oh, so the question is whether I'm distributing on Y and localing on X. No, you mean the top one?
Yeah, is that a typo or
no. So I am. Yeah, you're right. I was just typing this quickly. I see where you're coming from. I'm sure I could make up a use case that would validate this, but I'm gonna just go. Yeah, you're right. But you kind of get the idea, though, that I've had to say a lot to do that simple thing. I am in the room with lots of people that know ECL, so that's probably not the first time that's going to happen. So let's have a look at other languages. How do other languages cope with this kind of, I want to get a workflow going and I want to be able to read it easily? Here's R. So you can see we have nice key verbs going on here. So we want to read CSV. We want to select some columns. We want to mutate one of those columns. Let's do a group by. Let's do a count. Very clear kind of verbs associated with what you want to accomplish. And if you use the pipe functions in dplyr as well, you can make it even simpler. You can say, look, read the CSV. From that CSV, select these columns. From that, do a transform operation. Now it's more of a workflow that you can just read and work through. And again, you're removing redundant code. There's one fewer parameter in here than there was before. SQL, it's also lovely, like select, count, from, group by, like just short, snappy words associated with what you want to accomplish. SQL can get a bit verbose later on, but when you want to do something simple, it's quite easy to communicate it. Python, being the second best language for any application you can think of, also is quite good at this. And this is the Zen of Python, or at least the first half of it. And I think that there's a few things here that I think are relevant. Things like sparse is better than dense, flat is better than nested, and most importantly, readability counts. As a developer, it's your job to write something that other developers can read. Like, if it's a bit less efficient, that's probably fine if your person sitting next to you can actually read it more easily, because that person's far more expensive than the PC you're running it on. And that is why Dapper exists. It's basically a package to make ECL cleaner, neater, and easier to read, so that poor data scientists like myself that maybe don't have a comp-sci background can navigate it a bit more easily and accomplish what they want to do quicker. And you will notice my major was not in art. I apologize for the logo. I'm taking if anyone wants to volunteer for a bit of logo design, I'll definitely hear it. So let's work through an example. My example here is I'm going to work through some Star Wars data sets. I'm going to explore the kind of people in the Star Wars universe, and I'm going to answer a critical question, which is, what is Jabba the Hutt's BMI? Which we have all wondered on occasion, I'm sure. So let's start simple. Let's get some data in and let's load Dapper. You'll note that we just import example data. There's a few data sets with Dapper that will let you do these kind of exploratory test things. And we import it as TT. So Dapper's transform tools is imported as TT. That's important. Under the hood, this is all macros, which means it needs to know, it needs to be able to reference itself. So if we import it as TT, it kind of references TT within the scripts. Haven't solved that problem yet. It's an outstanding one. And let's have a look at some data. So we'll load our Star Wars data set. We're going to get a row count. I'm going to look at the head. There we go. And you'll note here, this is an output from ECL Watch, that you've got, does that work? No, it doesn't work. On the bottom, you can see we've actually got the outputs named. It's not just result 1, it's not just result 2. It's count of Star Wars, it's Star Wars. So it automatically kind of reads these things and says, oh, the variable's called Star Wars. You probably want your result set to be called Star Wars, just thinking. And so it does it automatically for you. And whereas otherwise you'd have to put comma, output, name, and all the other bits. You see, I'm preempting myself through this whole presentation. I've just got a bit excited. I apologize. Okay, so you'll notice that in the species column of here, we have quite a few blanks where we just don't know what species the character is. That's understandable. The books aren't considered canon, so there's a lot of information you've got to kind of fill in from the films, and basically the stuff that's not used in the script. I would like them to say unknown though, just so I don't have blank strings, because there's no NA in ECL, which is fine. We'll just use unknown. And to do that, I use mutate. So I'm altering the table in some way. So if species is blank, call it unknown, else call it species. You will note here that I don't have any left and any self, because 9 times out of 10, that's a superfluous bit of code. Like, it should be self-evident what's contained within your data set and what is not. What I've actually done under the bonnet is it actually works out all the column names, reads through your query, and then it kind of just alters what you've given it to give it left and self in a project statement. But it does all that kind of under the covers rather than something that you have to work out yourself as you're going through all your code. Okay, so let's make us a BMI column. I'm going to use my mutate again. I'm going to divide my height by 100 because my height's in centimeters and it should be in meters, which if you watch the webcast of this same presentation is an error I didn't catch, and Jabba's BMI is like 2.1. So it's a correction. You can tell that I don't really understand BMI particularly well. And then I'm going to, instead of mutate, I need to add a new column. So I'm going to use a different verb. I'm going to append. I'm going to append a real type column called BMI. I'm going to make it mass divided by height squared. And then I just want those 2 columns. So I'm going to run a select statement. So just select BMI and then 2 columns of the set that name what I want. There's my real, and you'll notice that these are in a string. So what it's doing there is it'll take the string, it'll break it apart, and it will use them as column labels when it's doing its project. And that happens quite a bit in Dapper. What you want is to give something a whole load of columns. You just put it within a string, and it will parse it out later. And there we go. Luke Skywalker, a nice healthy 25.6. Jabba's not actually on this one, although Owen Lars is probably on the heavy side. In order to find Jabba, we're going to have to sort it. And I'm going to sort it by BMI, just working on the general assumption that Jabba the Hutt is probably the heaviest person in Star Wars. I'm happy to be corrected. As far as I'm aware, this is accurate. So again, you see this kind of this string operation at the end, so I could give it 4 or 5 columns if I wanted to, and just it would sort by all of them in order. And there we go. Jabba the Hutt's BMI is 452.6 recurring, which is that's pretty good. We've got Sebulba's only 13. That's the guy that sells Qui-Gon Jinn the hyperdrive when they're on Tatooine. He is like a little tiny flying thing, so that's understandable. And Yoda's only 8.5. Lovely. So I think that's one of life's great questions answered. I think my work here is probably done. But we do have a few more bits and tips and bits of functionality that you might want to have a look at. Because there's plenty of other questions to ask on a data set that contains all the species, hair colors, skin colors, heights, weights, spaceships, and films associated with Star Wars. I'm going to focus on one question first and foremost. Has anyone noticed that despite this big galactic empire, virtually everyone is human? I'd expect some fantastic array of organisms. But if we do a species count here, so again, and this is count n, so this is a grouped count. So this is saying, take every species name in the list and count how often it occurs, which in ECL is like a table, and then you need a new record set with a group column, and then a count, and then maybe a local or a merge, I forget what you need. You can just do that with sorted BMI, and then all the columns that you would like to count on. And there we go. 35 humans and only 5 droids. That's 7 times as many humans as the next most populous race in Star Wars. I think they could try harder. There's also some pretty exciting eye colors. We can do a select statement again, and here we see another functionality. So this replaces your sort, dedupe, distribute, that one, with a single command, which is tt.distinct, which will just distribute by all your columns, sort them, deduplicate, or with all the locals put in for you. If you would like to do something more fancy, so let's say you wanted the most recent date, so you'd want to actually add that date as a sort parameter, but not as a dedupe parameter, you can use arrange distinct, which will allow you to vary the things that you're spreading out on and arranging on. I like this, so I'm going to save it. I'm going to use tt.toCSV to save a standard formatting CSV, and to Thor to save a Thor file. Again, removing all the extra commas and brackets and commands and things. It will even take expire if you fancy giving it expire as well. And you will also notice, now this isn't an error, I've not put a little wavy thing at the start. I do know what it's called, I just can't pronounce it, so I'm going to call it a wavy thing. The thing that basically says put it in the root rather than put it within Thor. I always forget that, and then I can never find my file ever again. So I've made my functions put it in for me automatically. I'm not aware of a use case where this causes problems, but I'm happy to be corrected. It's just one of those little things that winds me up all the time.
It will be Thor. It will be the name Thor, if you're running one, or
Yeah, but if you don't remember that, it ends up getting put in there, and then you can't find it because you expect it to be in the folder with the wavy line. Oh, sorry, yeah. So the question was that, well, it was more of a statement. It was if you forget that in a normal write command, that would be Thor, : Rob, temp, Star Wars, CSV. So you're correct, it's not lost, but it's not where you expect it to be, which is something that keeps catching me out. Yeah, I think I just feel like I want to hammer this point home a little bit. I want to do a quick side-by-side. So here is the first half of this presentation in comparison side-by-side form. On the left, you've got Dapper. On the right, you've got base ECL. Now, similar lengths, but you notice, like I was saying, there's less of a nested structure on this left-hand side. And you could probably give this to someone that doesn't know ECL, and they could have a fair crack at telling you what it's doing. It's printing out bits of the data set. It's mutating columns. It's adding columns. Like, there are very clear words associated with it. Whereas on the other side, you've got lefts, you've got nesting, you've got self equals BMI and lefts. It's just slightly less clear, and it's slightly harder to get through. But the true power of this actually sits here. So this is the second half of this presentation where I did a group count. I did a distribute as well. And you can see it's much more to the point. It's just exactly what you want it to do. Whereas over here, you've got those complicated outputs. It takes far more rows to get your group counts out. It's just a bit harder. And again, I'm happy to be corrected on this ECL. I think it's right. But it's a far easier way to communicate what you found and why you found it as well. And with these head statements, it's far easier to navigate your results as well, because you can just run that whole script, and because you've got nice names for your variables, you can just pop along it and go, okay, that was that, that was that. And there's plenty more that Dapper can do. All of these are from the GitHub. We've got a full README and then graphics associated with all the different columns and transforms that you can accomplish. There's some really good stuff for filtering two data sets by one another. And I've not talked about things like flagging duplicates as well. You can do like true, false for duplication, that kind of thing. Again, that's something that's not hard to do. But when I'm thinking of doing it, I don't want to stop and write the right joins and do the transforms to do it. I want to get it done and then move on to the next stage of my thought process so that I can continue to work. Now, so that's Dapper. Now, I'm aware that was only 10, 15 minutes, and I have planned for this, don't worry. But does anyone have any questions about Dapper itself before I talk about some other exciting surprise topics?
How do you actually use it?
So it's a bundle. That's actually on this. That's on the slide I've just got rid of. So it's a bundle. So if you've used bundles before, they just live on GitHub, and you can install them. So on a command line, when you've got ECL on your path, you can just type that in, and it will install Dapper. And then you can import it simply with import dapper.transformtools as TT, and then you can use it as that script was using it, just TT dot and then whatever you want to do.
And can you mix and match with regular ECL?
Yes, it is. So under the hood, yeah, that's the right way around. It is regular ECL. So all it is a selection of short, snappy macros. I don't think there's anything that's over 10 lines, but it just makes it easier. And if you expand all the macros, it is just a big ECL script.
So you use macros, which is a neat idea. Is there anything you want to do that requires more capability than macro?
I'd like to get the macros working a bit cleaner, because importing Dapper as TT has to be enforced because the macros refer to themselves as TT. So that can get a bit hairy if someone doesn't do that. I'd like that to work a lot better. We have had more complicated things that we've had to do in the team. So for example, we do quite a bit of geo work with polygons and lines and intersects. And for that, we tried to do some ECL stuff. And in the end, what we did was we wrote a series of Python functions in ECL. So over the top, it looks quite similar to Dapper, but underneath, it's far more complicated because, of course, you need Python going. And that's how we've solved that increased complexity. Yeah.
Is that part of Dapper?
There's no Python in Dapper, no.
How do I get that increased?
So
Go to work for Proagrica?
well, so all of this is in public domain. You can see you can't see it now because I'm moving to a different part of the presentation. Everything is on our GitHub, which is github.com/odinproagrica. I'll make sure it's on the screen again in the not too distant future. But if you want our geo polygon tools, this is very much an alpha package. It's not quite finished, but it seems to work fine. It's called Wally. Anyone that ever played Monkey Island hopefully gets the reference. And that's also on our GitHub, along with setup instructions and a Docker image for development purposes as well. So, as you may have noticed by me navigating around my presentation, I have a few other things in here as well. So my team uses quite a bit of HPCC and quite a bit of ECL. So Dapper is just one of the process improvements that we've developed to make our lives go a bit better. The other one I kind of want to use a few minutes because I've got 15 minutes left, haven't I think? Yep. I want to introduce you to something else that we've made, which is called HPCC. You will note my major was sciences, But I think you get the general idea. It's an integration between Python and the HPCC systems. So it answers a few questions and uses a few of the similar kind of principles of Dapper, which is how can we make it easier, more repeatable to use, and make sure that when we're trying to do something, it can form part of our standard workflow. I don't know about you, but possibly the most infuriating thing is having to go through the landing zone to do anything. You want to put a file up there, you spray it to the landing zone, you put it up on the landing zone, you spray it, you want to take a file off, you find the logical file, you put it in the landing zone, you download it again. That is manual, and it can get frustrating at times. So HPCC, the whole principle was that we can find ways to shortcut that process using ECL.exe and also the APIs that come with the ECL web tools. It can be used for spraying new data, running scripts from something like a Jupyter Notebook, getting results of queries and files, and also it's got some Docker tools in it so you can do ECL dev when you're off-site. So all of this can be run from Python Notebook, and you can install this using pip. Just pip install HPCC. It's all on all the Python libraries. And you can see all the kind of verbs that I've been talking about again, things like get, spray, run, and connect. And I've also imported pandas because I'm going to walk through some more Star Wars with you as well. For the purpose of this demo, I've also made a throwaway function that you may see, which is just write some ECL code to a file so Dapper can use it. In reality, I would be using Notepad++ to write my ECL, and then I'd fire it up with HPCC. It has a syntax checker within it, so you don't have to worry about syntax checking stuff before you send it. It will do the syntax check and raise before it even gets to the server if it has to. Incidentally, the highlighting you see on this Notepad++ is also on our GitHub as well. So if you want to use ECL with some Notepad++ highlighting, then you can just download and install that. So I'm going to be doing some dev on the train because I commute quite a bit. I'm going to need a HPCC container for this. I'm going to I have to have Docker installed on my computer. I'm going to boot up a HPC container. I'm going to be running on version 6.4 because I'm old. And I'm going to keep it in my environment so I can shut it down later. And once I've got that, all I need to do is create a connection to my server. Now, this is just my local box that I've just spun up, but it could just as easily be a production environment. It could be our sys-test. All you need is the web address, your username, your password, and everything else is handled. And it will test that connection when you make it and store it. So all you have to do is give it this object, and it knows where your HPCC is living. And you'll notice as well, this is a Dapper program. So I've imported my Dapper repo. This is the same thing as going to ECL IDE, adding a folder, and that folder being a source that you can import from. It just does that for you automatically as well. So you add it to your connection, and then all your code is available to you to use from your ECL scripts. So can you see that? Yeah. Let's do a quick example data. So let's take our Star Wars example. We're going to run a script that basically just prints our Star Wars data. And then I'm going to just do a histogram of it just to show that I can do something in a Jupyter Notebook instead of just printing the table. There we go. So that's the height in centimeters of everyone in our Star Wars table that we saw earlier. And I've done that simply by making the table, pulling the table down, and then doing a basic pandas plot operation on it. I've not had to go anywhere near my landing zone, and I've not had to go anywhere near putting files up or down or despraying stuff. And here is the whole script. I realize the red on black is quite poor in this lighting. Is this the light switch? There we go. And now if you get bored, you can have a nap. So this is the whole script that we ran earlier. So you can see it's basically just everything copied and pasted into one single command. And I'm going to run that as get outputs. So this is a command that specifically says, I've got more than one output in my ECL code. Please return all of the results as a dictionary and let me deal with them later. And that's exactly what you get. You can see on the dict keys here, these are each of the outputs for the Star Wars data set we were looking at before. And then, just because we need them to look at, this is a box plot of BMIs in our data set. And you can see there's Jabber outlier to the end sitting at the top there. We can also spray files up. So this is a file that I got off Tinternet that lists someone's whole Star Wars collectibles collection. Everything on their shelf and in their cupboard and in their attic, is listed here, along with how much it costs, like what year it's from, and even kind of what film it's based on. So I'm going to spray that up into my HPCC using spray. And then I'm going to re-download it using get. So just as an example, obviously if I've got it in memory, I wouldn't have to do this. But 2 steps, I can put the file up, I can pull it back down again by just giving the file name, and then I can print something. So you can see that most of this person's collection actually comes from the Clone Wars, which is acceptable, but there's quite a high bar here for episode 1. That's just here. And that indicates that I wouldn't get on with this person. So the get Thor file operation is actually significantly more efficient than the get output. So the get output simply goes into the work unit and says, can I have that data, please? And that's a single-threaded operation done via the work unit. Whereas get Thor file will actually use chunking. It will go and look for the length of the file, break it up into pieces, and then make several API requests at once to get the file as quickly and as efficiently as possible. So it's actually a much better way of getting really large files down, because it doesn't break your work units. And then we'll just do some saving. We'll run a script. So I use this for feature creation and that kind of thing, where I don't need the data necessarily here and there, but I do want something to run on the box. So if I'm going to produce a model of some description, do some stats, I want to run a load of scripts in parallel and join them together later, I might just use a run command, which does exactly the same thing. This one actually has an error in it. I did that on purpose, but you can see that you do actually get a full kind of syntax error if you make a mistake with HPCC. So again, it will tell you something's gone wrong. It'll tell you where it is. You get this kind of similar feedback as you get from the IDE. So it's quite useful.
Got that syntax errors while running the work unit or by doing the syntax check?
So this would have done a syntax check first, and it would have fired back the error. Depending on what the error is, what's it saying? Yeah, unknown identifier for dot. Yeah, so I'm using something that I've not imported because I haven't imported Dapper here. So this would have failed as the syntax check before.
Because it showed like in failed work unit, right? That means it's happening after you ran the code. Right.
That's just my report. So it's failed work unit or command line call. So it's made a command line call to syntax check.
Okay.
And then it's raised from that. I might raise that as an issue now you said it, just to make it a bit clearer.
Okay.
Yeah, it tries to keep its hands off your HPCC instance unless it absolutely has to. And it cleans house quite well as well. So if it does make a huge work unit, it will get rid of it for you. It tries not to cause problems, because I was developing this while we had a HPCC expert on site, and he was basically just watching me all the time, making sure that I wasn't doing things to harm his cluster. And so I've tried to make sure that it's relatively quiet.
Okay. Because in macros, right, mostly we'll not get the errors when we do syntax check because the code is created during the runtime.
Yeah.
We get some error during only when we run the work units, right? With your Dapper tool, is that and bottleneck for us? We have to run the work unit and see where it's failing, or syntax check will work? So
certainly in 6.4, the syntax check will catch them.
Okay.
It's quite infuriating because if it's within a macro, your error message is like the 4th one down. Mm-hmm. So if you double click on the first error, it'll take you over to Dapper into one of the macros, and you don't want that. If you go down, it'll say which macro failed, and that's where your error is. So there is a little bit of a mental effort involved there.
Okay, thanks.
So now I am actually going to run that script. I'm going to import Dapper like I should have done in the first place, and I'm going to go and get my Dapper Star Wars data set back down. So this again is get Thor file, and this is the file that we've been playing with most of the presentation, just outlining all the Star Wars characters and where they're from. And I finished. So I'm going to stop my container, shut it all down, walk away and go home. But everything there has happened within my Jupyter notebook. I've not had to go to Docker, I've not had to go to a command line, not had to go to the ECL IDE, and I've not had to go to ECL Watch either. It's nice and contained, shareable, and repeatable. And that's kind of the thought behind HPCC. And that is also, it's available as a pip install. It's on our GitHub, Odin Proagrica /HPCC. And we also have other cool stuff in our general GitHub as well. There's a syntax check wrapper, so you can syntax check lots of files more efficiently, and also a few other bits and bobs that we've been working on. That's pretty much.
Excuse, can I ask a question about, because I'm learning the machine learning and the GPU, I know the Python is master at how to use the TensorFlow to using the GPU and use the random forest tree, use the string, that be much more better. I remember you also using the CUDA to combine to use the GPU. Our ECL is master at how to using parallel to using CPU to calculate, to prepare the data. And maybe we can combine together. It's just like you also using Python and our ECL just our research system to combine together. It's just that I can utilize the CPU efficiently and also use the GPU efficiently. You can combine together, that'd be much more better. But this is only my idea.
So I think, so you're outside of the realms that I usually tread in there. There are people, I've seen a poster here about using the GPU in HPCC and kind of getting CUDA stuff running. I'm not quite sure how that's done. For me, what we do for machine learning is we would create our features using Dapper. We'd use HPCC to transfer that to Amazon and S3, and then we'd run something like SageMaker, or we'd just spin up an EMR or something like that and use like a mainstream ML library to do it. I'm not saying that's the best way, but we've been doing this for 3 years, and there just wasn't the capability to do that in HPCC when we started. So that's kind of how I get to use the GPU to do machine learning, is I put it somewhere else using HPCC.
Yeah. I know the GPU in our HPCC previous they using Java to build, but I remember for the school most of them they use the Python to just add machine learning. So in my idea that you just and Novel is support the GPU much more better than the other graph cards. Maybe you can combine them together. Just we separate two toolbars. First part is just the data preparing, and just data preparing, we will use our HPC system, use the ECL to preparing the data. After data preparing, we use the GPU to combine CUDA together to use the machine learning algorithm to calculate, because CUDA is much more better than for the integer, how to add it, that'll be much more better. And after that, we can get a result much more faster and much more accuracy.
Yeah, no, I completely agree. It's, and I say there's ways and means to do that. But increasingly, I think they sit on HPCC. I just don't use them.
Okay, thank you.
What? You have a question? Oh, okay. All right. I think that we are just about out of time. Did you have any other slides, or did you?
I've got loads, but I think we've reached a natural breaking point. I've got my mugshot, which I thought was
yeah,
especially
there we
prepared.
go. That's the most important.
I'm just glad when I asked for Obi-Wan as my mugshot, I'm just glad she chose the Ewan McGregor one and not the Alec Guinness one.
All right, well, thank you, Rob, and I think this is a great contribution and tool for our developers and the community, so I appreciate that.
Thank
So
you.
we are going to have a 10-minute break and then proceed to your second breakout rotation that starts at 2:20 to 3 o'clock. Okay? Thank you.
Cheers.